Welcome to the first chapter review. We are only doing sections 1.1 to 1.3. We have a quiz on Monday. This is your review sheet, and these are the types of problems that we can expect to see on the assessment. So let's start it up. So first of all, it says in exercises 1 through 12, solve the equation, justify each step, and check your solution. We're going to do some of that. We'll do all of the parts to begin with, and then we will sort of be a little bit more efficient moving past that. So first thing we need to do is identify the variable, which is W. And now we have to ask the question, what is happening to the variable? Well, what's happening to this variable W? 4 is being added to it. So we're going to use the inverse operation. Use the inverse operation. That's the key word. So the inverse operation, the inverse of adding 4 would be subtracting 4. And we have to balance the equation. So what we do on one side, we must do to the other. This positive 4 and negative 4 cancel, leaving us with our variable isolated. And 12 minus 4 is going to give us 8. So justify each step. We're going to subtract 4 from each side. Check your solution. Well, we're going to take that starting problem, and then we're going to substitute what we think W is. We solve for W, and we think it equals 8, and we won't know until we check. And when we check, it's not just plugging it in. We have to simplify this left side. 8 plus 4 equals 12. And then we bring down this right side. And as long as the right side equals the left side simplified, we know that this is a correct solution. We've solved correctly. Negative 2 equals y minus 9. What's happening to the variable? First of all, my variable is y. What's happening to it? 9 is being subtracted. The inverse of subtracting 9 is adding 9. These cancel. Negative 9 and positive 9 cancel. You're left with y. And negative 2 and positive 9. This is not addition. We are subtracting, and we have to subtract the smaller value from the larger value. 2 from 9 is 7, and then I have more positives than negatives, so my answer is 7 equals y. We don't have to write y equals 7 like we had w equals 8. The variable can be solved and isolated on the right side. We're going to take that starting equation. We're going to plug in 7 for my variable. We're going to simplify the right side. And does the left side equal the right side? Yes, it does. My variable is b. It's being subtracted by 19. The inverse of subtracting 19 is adding 19. Negative 19, positive 19 cancel, leaving me with b. My signs are the same. I have positive 35, positive 19. So we're going to add those. Carry 3, 4, 5. And it gives us 54. That doesn't look like a 5, Mr. Mac. Now it looks like a 5. 54. Let's check it. B minus 19 equals 35. My B value is 54. Minus 19 equals 35. That's a weird 5. 9 from 4. We got a carry. Goes in 5 times. 1 minus 5 is 1 minus 4 because we had to borrow. 35 equals 35. Good. All right. Now we'll move a little bit faster. My variable inverse of adding 9.6 is subtracting 9.6. Subtracting 9.6. We get n equals, I have negative 8.3, negative 9.6. The signs are the same, so we will combine and keep the sign. Two negatives only make a positive when you're multiplying. Here, we are adding the two terms. So this makes 9 Bring down the decimal point. 8 and 8 is 16, plus one more is 17, and my answer is negative 17.9. So here, when we ask what's happening to the variable, it's being multiplied by 7. The inverse of multiplication is division by 7. 7 over 7 gives us 1, 1q. That's how we isolate the variable. Negative 35 divided by 7 is negative. A negative divided by a positive is negative. And then 35 over 7 is 5. So key things, the inverse of multiplication has two of them. One, easy. The most logical is division. The one that we tend to forget is multiplication by the reciprocal. And oftentimes we do that when there are fractions involved. So very important for us to remember this key, this very important part. I'm going to get rid of that 6 so we can see it. Okay, what's happening to the variable? It's being multiplied. It's being divided by negative 2. The inverse of dividing by negative 2 is multiplying by negative 2. We're just inversing the operation. So that number will still be negative. Instead of division, it's multiplication. So 2 in the numerator, negative 2 in the numerator, negative 2 in the denominator, cancel to make 1. That leaves your n alone, negative 5. Negative 15 times negative 2. A negative times a negative is a positive. And 15 times 2 is 30. I'm going to get rid of that again because it's in the way of my... Now here is a here's a fraction multiplying my variable. Remember, the inverse of multiplication is also multiplying by the reciprocal. The reciprocal of 3/5 is just flipping it. What is in the denominator goes in the numerator. What is in the numerator goes in the denominator. And these cancel and leaving us with 1. What you do to one side, you do to the other. I'm not going to multiply 9 times 5 and make 45 thirds and then have to reduce a big fraction. I see that my denominator and my numerator are multiples of each other. So 3 goes into 3 once, 3 goes into 9 3 times. Now I'm left with 3 times 5, which is 15 over 1. Well, 15 over 1 is equal to 15. You must write 15. You cannot write 15 over 1. That can be simplified. Let's look at the next one. Next problem, what's happening to u? It's being divided by 2 pi. The inverse of dividing by 2 pi is multiplying by 2 pi. It doesn't say to round this answer, so we can leave it in pi. 2 pi times 10 leaves me with 20 pi equals u. I don't have to simplify it any further. That's fine. If it says round, that means we have to substitute a value in for pi because it is equal to a numeric value of, or an approximate value of 3.14, but that's not the case here. All right, let's look at number 9. Number 9, what's happening to b? It's being divided by 2. The inverse of dividing by 2 is multiplying by 2. When I write that, I want it to look like it's in the numerator because when I multiply 2 times 3/8, that denominator and numerator have a common factor of 2. 2 goes into 2 and 2 goes into 8. 2 goes into 2 once. 2 goes into 8 4 times. So on the left side, we're left with 1 times 3 over 4. So 3/4 equals... Numerator cancels with the denominator. Any number, anything multiplied by its reciprocal is going to leave you with the variable by itself. So b equals 3/4. All right, number 10. 10, what do we got here? 10, sorry. Perfect. What's happening to the variable? It's being multiplied by 7.2. The inverse of multiplying by 7.2 is dividing by 7.2. And now we get this fraction with a decimal in it. And we can't leave it like that. We must move those decimals out of the fraction. We can't have it as our final answer. So moving it one place in the numerator, you must move it one place in the denominator. You get 108 over 72 equals W. Now, I know my multiples of 9. 9 goes into 108 12 times, and 9 goes into 72 8 times. And now we can also still simplify that even further. Just because we do it once doesn't mean that we're done. What goes into 12 and 8? 4. 4 goes into 12 3 times. 4 goes into 8 2 times. And my answer is 3/2. So lots of work to do. Notice I'm not stopping. And notice when I am simplified. We have my variable r. We want to find that variable. What's happening to my r? 3 pi is being added to it. The inverse of adding 3 pi is subtracting 3 pi. When we subtract 3 pi, they do not cancel. That's like having 9 pizzas minus 3 pizzas, and that would leave you with 6 pizzas. It doesn't leave you with 6, it leaves you with 6 pizzas. Very important there. They only cancel when they are being multiplied or divided. Here we have a mixed number equaling a variable minus 1/2. My first step is I'm going to convert this. Okay, it's going to be negative 13/10 equals x minus 1/2. Now I might have some more work to do because my denominators are not the same, but what's happening to my variable is being subtracted by 1/2. The inverse of subtracting 1/2 is adding 1/2. And instead of writing adding 1/2, I need common denominators. So I'm not going to do 1/2. I'm going to find the equivalency of 1/2 in tenths. So 1/2 is equal to how many tenths? Let's move that down. 1/2 is equal to how many tenths? Well, 2 times 5 equals 10. So if I want it to be equivalent, I have to multiply it by the same number. And 1 times 5 is 5. So this is actually 5/10. Now we can combine these. This is positive 5/10. This is negative 13/10. 5 from 13 leaves us with 8/10 equals x. And I'm not done because I have to simplify. Make sure, and negative. I almost made a mistake. This is a negative. I have more negative, negative 13, positive 5. So my answer is actually negative 8/10. And I'm going to simplify that. I'm going to simplify it to negative 4/5 by reducing it by 2 over 2. And negative 4/5 equals x. Number 13 through 17 says, write and solve an equation to answer the question, the world record for the fastest 100-meter sack race is 39.91 seconds. What is the athlete's average speed to the nearest hundredth of a meter per second? So the average speed, so A equals average speed of meters per second. So there's your hint, meters per second. So meters is a distance. Do I have a distance in this problem? Yes, I have 100 meters. So I'm going to put 100 meters divided by, that's the per, and then seconds. Okay, my seconds is a time. So I have 39.91 seconds. And notice that gives me meters per second. Now they are looking for an equation where you get the unit rate. So I want meters per 1 second, not 39.91 seconds. So this is a good way of doing it. There's lots of different ways you can do it, but this setup is correct because I get my solution automatically. So I need to divide 39.91 divided by 100. I'm going to put the decimal because I'm going to have to move it, because when we divide by decimals, we have to move that outside decimal, 3,991. And if I moved it 2 places on the outside, I have to move it 2 places on the inside. So my new number is actually 10,000. And my decimal is here now because it was 100 and I moved it 2 places. I'm going to bring it up here. 3,991 goes into 1, no. 100, no. Or 10, no. 100, no. 1,000, no. 10,000, yes. It goes in, I'm going to say 2 times. So 2 times 3,991 times 2 is 2. That's 2 times 9 is 18. 2 times 9 is 18 plus 1 is 19. 2 times 3 is 6 plus 1 is 7. So 7, 9, 8, 2. We're going to subtract. I can't take 2 from 0. I got to borrow. I can't borrow from 0. I can't borrow from this 0. I can't borrow from this 0. So I'm going to borrow from this. That becomes 10. Now I can borrow from that, and that becomes 10. I'm going to borrow from it, and that becomes 10, and I'm going to borrow from that. So 2 from 10 is 8. 8 from 9 is 1. 9 from 9 is 0. 7 from 9 is 2. So now I add a 0 and bring it down, and I have 20,180. So what's that going to be? That's going to be like 3,991 times 5, maybe? So 5 times 1 is 5. 5 times 9 is 45. 5 times 9 is 45 plus 4 is 49. 15 plus is 19. So yeah, that's pretty close. 1,995. Subtract. Can't take 5 from 0. Got to borrow. 5 from 10 is 5. 5 from 7 is 2. 9 from 1, you can't take it from 0. So we got to borrow from the 2 to make the 0, 10. And now I can borrow from 10 to make 9. And that becomes 11. 9, 10, 11 is 2. 9 from 9 is 0. 1 from 1 is 0. So I'm left with 225. Does it say to round? Oh, to the nearest hundredth of a meter per second. So, sorry, I put 5 there. Sorry, that was my 5 to get my 19,955. So in order to round to the nearest hundredth, I got to go out to the thousandths. So I'm not done. I'm going to add a 0, bring it down. 3,991 does not go in. So I got to add a 0 here because I can't make it. I got to add a 0 there and bring it down. And now 22,500. So what's that? Let's see that number. 3,991. That was really close. So I'm going to try 6. Let's see what happens here. 6 times 1 is 6. 6 times 9 is 54. 6 times 9 is 54 plus 5 is 59. 6 times 3 is 18 plus 5 is 23. 18. All right, so maybe 5. 5 was my biggest, so 5. So I'm going to put that 19955. We'll be able to see if my math is correct. Can't borrow, so 4 becomes 1. Borrow 9 becomes 1. 5. 5 from 9 is 4. 9 from, no, that's 4, so I got to borrow. 9 from 14 is 5. I can't take 9 from 1, so I got to borrow. 9 from 11 is 2. And this number is smaller than this, so I did do the biggest number. So there's my number. So it is 2.505 meters per second. Now they say round to the nearest hundredth, so my average speed is going to be 2.5. Since we're rounding to the hundredths place, we look to the right. It tells me to round up. 5, 6, 7, 8, or 9 tells me to round up meters per second. And that would be the answer. A lot of work there. Lots and lots of work to do on that one. That was definitely time consuming. And if you're not proficient at your times tables and your division, then that's going to be even harder for you. So make sure. Oh, that was not good. That was not good. Where does that go? That goes right here. Let's do this. Sorry. Let's do this. Grab you also. Good. Group. Let's move it down a little bit so it's out of the way. Perfect. All right. That was not 60 seconds. That was not a 60-second problem. The width of a laptop is 11.25 inches. The width is 0.75 times the length. What is the length of a laptop? So we've got a laptop. A laptop looks like this. It's this, this, and this. So the width is 11. So this is width. We'll label this width. The width is 11.25 inches. And the length, no, the width of the laptop is 11. The width is 0.75 times the length. So the width is, so if our length, let's change that, sorry. Let's make the width over here. So this will be the width, and this will be the width, because length kind of goes this way. So this is our width. So our width is 11.125 inches, and we'll make this the length, because that kind of makes more sense. And it is, the width is 0.75 times the length. So the width is 0.75 times the length. So there's our formula. So width equals 0. And we know what the width is. So, okay, I got it. I got this. So we write this. The width is that. I don't know what the length is, but I do know that the width is 11.25 equals 0.75 L. We're going to divide by 0.75, divide by 0.75, and now we have a decimal, 11.25 over 0.75. We're going to move that decimal point 2 places, that decimal point 2 places, and we get 1125 over 75. Let's reduce this by quarters. So I know that 25 goes into 75 3 times. There are 3 quarters and 75 cents and $11.25. So let's think about this, $10. So there are four quarters in each dollar. And if we have 11 of them, that's going to be 44, plus that extra one is 45. I like that better. If there are 4 quarters in each dollar and we have $11, 4 times 11 is 44, plus this extra quarter. And now we need to reduce this, and that reduces to 15. So and this is for L. This is L equals. So the length is 15. Let's look at the unit. Inches. Good. That's a little bit faster. Okay, I like that. That was much better, and we like that. Number 15, the temperature at 10 a.m. is 12 degrees Fahrenheit. So if we draw a clock and we draw 10 a.m., that's the big hand. This is 6, this is 9, this is 3, this is 12. So 10 is going to be there. So at 10 a.m., it is 12 degrees Fahrenheit. The temperature at 6 a.m. was -7 degrees Fahrenheit. Whoop. Okay, so one of the things, since we're talking about a time before this, I'm actually going to move it over here. And now I'm going to draw my clock. at 6 a.m., this is 6, 9, 12, 3 at 6 a.m. So big hand is here. Little hand is going to be here. We can draw a little circle thing there. Okay. So at 6 a.m., it was -7 degrees Fahrenheit. So how many degrees did the temperature rise? So if we end at 12, what's going to equal 12? So -7 plus what temperature is going to equal 12? That would be how I would write this problem. If we start at 7, plus what amount of degrees will take you to 12? And if we're going to solve it, you're going to add 7, because we're looking to get rid of the -7. And we get T equals 18 degrees. Oops, 18. Hello, that was weird. 19 degrees. I literally said 18. 19 degrees. So it will increase by 19 degrees Fahrenheit. We might want to do it increases by 19 degrees Fahrenheit. Good one. I like that. 16. The population of a city is 645 people less than the population 5 years ago. The current population is 13,500. What was the population 5 years ago? So the population of a city is 645 people less than the population 5 years ago. So 654. So I'm going to say F for 5 years ago. If we subtract 645 from the population 5 years ago, we're going to get the current population. Current. 5 years ago, current. Now, we know what the current population is, so we will substitute that in. The current population is 13,500. And so 5 years ago minus 645 would equal the current, and the current is 13,500. So let's get rid of the -645 by adding 645. Adding 645. That gives us F, the population. F equals population 5 years ago. And it's not a bad thing to write what your variables equal. And 5 plus 0 is 5. 4 plus 0 is 4. 6 plus 5 is 11. Carry the 1. That gives us 4, 1. So the population 5 years ago was 14,145 people. Another good one. After a party, there are 2/5 of the brownies you had made left over. There are 16 brownies left. How many brownies did you make for the party? So after the party, there are 2/5 of the brownies. Of is multiplying. Of the brownies you made left over. So this is leftover. So 2/5 of the brownies equals the leftovers. If there are 16 brownies left over, then we would plug in 16 for the leftover, and we get 2/5 B. Now, we're not going to, even though 2/5 is multiplying my variable, the inverse is division, but we don't want to divide with fractions, so we use the alternate, the second inverse of multiplication, which is multiplying by the reciprocal. We're going to flip this. 2 goes to the denominator, 5 goes in the numerator. Any number multiplied by its reciprocal leaves you with 1 and the variable. And what we did to one side, we have to do to the other. I'm not going to multiply 16 times 5 because I can simplify. Denominator, numerator. What goes into 2 and 16? 2 goes into both of those. 2 goes into 2 once. 2 goes into 16 8 times. And now we have 8 times 5, which is 40. So there were 40 brownies to start with. Number 18, problems number 18 and 19. The letters A and B represent non-zero constants. It just means that they can't be zero. Solve the equation for x, then find the values of A and B for which the solution is positive. So if we want to solve the equation for x, we're first going to add b to both sides. That gives me x equals b minus 5/9. So now it's saying, hey, what value for b would make the solution, my x, positive? So if I stick 0 in there for b, which it says you can't put 0, but we're going to start with 0, what happens to that solution? That solution is negative 5/9. If I put 1 or 5/5, or excuse me, 9/9, if we try that problem, right, if we do this, if we plug in 0 for b, we get x equals negative 5/9. And that does not work because it's not positive. So that's a no. If I increase my value, let's plug in 1 for b. So if I plug in 1 and minus 5/9, first of all, 1 is equal to 9/9 minus 5/9. Notice what value I get. I get 4/9. Now that value is that is a positive value. So that actually satisfied it. But can I get closer to 0? Where is that point where the no and the yes stop? So I can get smaller. Instead of 1, why don't I plug in? What if I plug in, 5/9? Whoa, what if I plug in 5/9? X equals, what if I plug in 5/9 minus 5/9? What do I get? I get 0. Now, that is not a positive value. 0 is neutral. But I found where it stops going. So any value bigger than 5/9, that was what I plugged in for b. When b is equal to 5/9, my x value is going to be equal to 0, meaning it's neutral. When my b value is less than that, when b is less than 5/9, my output, my x, is actually going to be negative. It's going to be less than 0. Let's write that. Let's write less than 0. Which is negative. So that doesn't work because my output needs to be positive. When b is greater than 5/9, then what happens to my output? My output is going to be greater than 0. And it's going to be positive. So that would be your answer. This is the answer you're looking for. When b is greater than 5/9, my output is going to be positive. A little technical, but this is important. This is good. You can work on hard problems. We want to be able to read it, put it in our brain, use it as experience. So we first have to solve for x. So let's first of all get rid of that 19 so we can show our work. Okay, let's, x is being divided by -7. The inverse of dividing by -7 is multiplying by -7. So we get x equals -7a. So what values for a? And we, again, will try a couple. What if we plug in 0? What if a equals 0? What if we have this and we plug in 0 for a? Plug in 0, we get x equals 0. Okay, that's pretty good. That's neutral. So this is the border. That's neutral. When we plugged in 0, when a was equal to 0. And so let's try, what if we try a number bigger than that? What if we plug in 1? So -7 times 1, we get -7. No, that's negative, so that didn't work. When we went bigger, it actually went negative. It went from neutral to negative. So let's try going smaller. Let's go in the other direction. What if we plug in Negative 1. Well, that gives us 7, which is positive. Okay, that's good. So if this is the border, so when x is equal to 0, we know our output, sorry, not when x is equal to 0, when a is equal to 0, my output, x, is equal to 0, so it's neutral. When a is greater than 0, my x ends up being negative, output, negative. And when a is less than 0, my output is going to be positive. So my solution is going to be what values? When a is less than 0 is going to be the answer to that. All right, that's a fun, again, good one, good logic, good thinking. That was 1.1. Now let's move to 1.2. 1.2 extra practice. 1.2 deals with multi-stepped. We're starting off with two-step equations. We're going to identify the variable. What is happening to the variable? Two things are happening. 3 is multiplying it, and 4 is being added to it. We're going to get rid of the addition and subtraction in this problem. So we will subtract 4 from both sides. A positive 4 and negative 4 will cancel to make 0, leaving us with 3x equals 15. 19 minus 4 is 15. Now 3 is multiplying. We're going to divide. We don't have to multiply by a reciprocal. We can use the most logical one. X equals 5. And that's my answer. So that's a nice one. It's a nice, gentle, easy starting problem. Nice little two-step. And, oh goodness, there we go. Let's move on to problem number 2. I'm going to get rid of this number so I can show some work. Actually, I didn't need that. I didn't need to do that. I could leave that there. All right. What are the two things happening? 5 is being subtracted. 4 is being divided. So let's get rid of the subtracting 5. By adding 5, we're left with f over 4 equals negative 9 plus 5 is negative 4. What is the inverse of dividing by 4? Is multiplying by 4. The 4 in the denominator cancels with the 4 in the numerator, leaving us with f. Negative 4 times 4 is negative 16. And that would be our answer. This is a good one. This one, a lot of students had a problem. It doesn't look like Chewbacca, but Chewbacca just entered the room. Because Chewbacca is, these two things are together. This is called a vinculum. And this 3 is underneath both of them. Important idea to understand that Q minus 7 over 3 is equal to Q over 3 minus 7 over 3. That 3 is under the Q and it's under the negative 7. That's what it really looks like. So if we were going to do a two-step here, we would add 7/3, but we don't like fractions. It's much easier. So this is that 1% problem where we're actually going to use multiplication first to get rid of it, because we can't subtract that 7. We can't get rid of the negative 7. So we got to get rid of that 3 first. What gets rid of a 3 in the denominator is a 3 in the numerator. So we multiply both sides by 3. They cancel. You're left with Q minus 7 equals 8 times 3 is 24. And now this is a one-step. Let's add 7. Q equals 31. And that's another good one. I keep saying that. Now, if you had it like this, let's sort of do that. Let's keep this idea, this understanding of that is if you have Q minus 7 over 3 equals 8, and we separated it like this, and you make Q over 3 minus 7/3 equals 8. Okay, we'll get rid of the addition and subtraction by adding 7/3, adding 7/3. Now, 8 equals how many thirds? 24. Very good. 3 times 8 is 24, so 24 thirds is equivalent to 8. And so now we have 24 thirds plus 7 thirds because we need common denominators in order to add fractions. So this is going to give me 31 thirds equals, let's make that in the proper color. That's 31 thirds equals Q divided by 3. Because these cancel, negative 7 thirds, positive 7 thirds cancel. Q over 3. Now the inverse of dividing by 3 is multiplying by 3. And any number multiplied by its reciprocal leaves you just the variable alone. This 3 is in the denominator. This 3 is in the numerator. They will cancel each other, leaving you with 31. Still the same answer. So both techniques work. Which one was easier? This one. So be able to recognize the uniqueness of this problem. This is unique. Let's do a little star. This is unique. This is not unique, but we do need to remember something. Simplify both sides before isolating. So if we have like terms, that's not isolating, that's isolate. Isolating. So if we have like terms, which we do, on the same side of the equal sign, we can combine them. So this problem now becomes 15 equals 6 minus d. Now that negative is with the d. This is a positive 6. So what gets rid of a positive 6 is a negative 6. So we need to remember to subtract. 15 minus 6 is 9 equals negative d. Remember that negative. Got to come. And also remember, negative d is equal to negative 1d. That's an important idea to remember. So there's a negative 1 here being multiplied by my variable. The inverse of multiplying by negative 1 is multiplying by negative 1. What? Because negative 1 times negative 1 equals positive 1, and it leaves you with your variable. Negative 1 times 9 is negative 9. Yep, I know. You're going to hear it again. That's a great problem. I love math. All right. We can simplify because these are like terms. Remember, like terms have two things in common. Two criteria. One, same variable. To the same exponent. And when we have like terms, we combine their coefficients. The coefficient is 5 and 3. If you have 5 X-ray machines plus 3 X-ray machines, you have 8 X-ray machines. And now 8 is multiplying. The inverse of multiplying by 8 is dividing by 8. X equals 28 eighths. 8 doesn't go into 28. However, you can reduce it. They do have a common factor of 4. 4 goes into 28 7 times. 4 goes into 8 2 times. And we can leave it as 7 halves. You do not have to turn it into a mixed number. Not necessary. Not necessary to convert. When we turn it into a mixed number or a decimal, that is called converting. Not necessary to convert. Just need to simplify. However, you must simplify. And that's what we did here. We went 28 eighths becomes 7 halves. You must simplify. Good. Number 6. Number 6, we have like terms. We have 9z and negative 4z. Since everything is being added and subtracted across here, we can combine those. So that is, we are able to combine these like terms because everything is adding and subtracting. 9z minus 4z is 5z minus 5 equals negative 5. Let's get rid of the things being added and subtracted. We got to get rid of the negative 5 by adding 5. we are left with 5z equals 0. We're going to divide by 5. And z equals 0 over 5. Now you need to understand that 0 over 5 can be simplified. 0 over 5 is equal to 0. Not 5, not 1. It's equal to 0. If we think of pizza, if you have 1/2, you're eating 1/2 of 2 pieces. I'm eating 1 out of 2 possible slices. If you have 2/3, I'm eating 2 of the 3 possible slices. If I have 0 out of 4, 0 over 4, I have 4 slices and I'm eating 0 of them. So I ate 0. That's why it's equal to 0. You like? And then if you have 5 over 0, well, you can't eat 5 slices if you have no pizzas. If you have no slices, you don't have any slices to eat 5. Eat 2 of 3, eat 1 of 2, eat 0 of 4. I can't eat 5 of this. This is no solution. Very important concept. Number 7, a gym charges $25 plus a monthly membership fee. You pay $574 to join the gym for 12 months. Write and solve an equation to find the monthly membership fee. Okay, a gym charges $25 plus a monthly membership fee. Okay, so you have your monthly membership fee. So let's write this: membership plus a $25 regular normal charge. You pay $574 to join the gym for 12 months, right? And this is monthly membership fee. Okay, this is getting technical. So, and you pay $574. Now, this is going to be important, and we join it for 12 months. So, if I take 12 times my monthly fee plus my 25 initiation fee, that's going to equal the 574. So I had to sort of adapt it a little bit with more information. So the correct answer, the correct equation is this. Okay? So that is how you're going to do it. Now we're going to solve. We're going to subtract 25. That's not fun. 12m equals 5 you can't take. That becomes 6, borrow. That's 9. 2 from 6 is 4. 549. We're going to divide by 12. Divide by 12. M equals, so 12 goes into that. Let's do some math. 12 divided into 549. Well, 12 goes into 54 4 times. That's 48. Got to borrow. 8 goes into 14 6 times. 4 goes 0. Bring down the 9. Hi-ya. Okay. 69. What's that going to be? 5 is 60. Let's make a decimal there. 60. 9. So that decimal goes there. We're going to add a 0. Bring it down. 90. 12 goes into 90. 12 goes into 90. 7 is 84. Yeah, I think 7 is 84. Borrow. 6, add a 0, bring it down. 60. 12 times 5 is 60. So the monthly dues are, that's a bad number that I was about to write. My monthly dues are $45.75 per month. And if I multiply that by 12 and add 25, I will get $574. Yes. All right. Now we got the multi-steps. Now we got lots of things happening to my variable. Chewbacca's in the room. So there are 2 techniques, 2 ways to do this. Method 1 is distribution. We can distribute. 3 times z is 3z. 3 times 7 is 21 equals 21. Let's subtract 21. That gives me 3z equals 0. We're going to divide by 3, and z equals 0. The other technique we could have done is to isolate Chewbacca. Distributing gets rid of Chewbacca. Notice Chewbacca's gone. Getting rid of the things outside of Chewbacca by dividing by 3 is another technique. These cancel. You're left with z plus 7 equals 21 over 3 is 7. And then we subtract 7. And z equals 0. Same answer. A little bit more efficient. That way, this other technique, this other method. Here we go again. We'll do the distribution. Negative 4 times a gives me negative 4a. Negative 4 times negative 12 gives me positive 48 equals 42. Now it's a two-step. Let's subtract 48. Negative 4a equals, I'm going to take 42, the smaller from 48, which is 6, and I have more negatives than positive. I'm going to divide by negative 4. And a negative divided by a negative is a positive, and I can't leave 6/4. I have to reduce that. 2 goes into 6 3 times, 2 goes into 4 2 times. So my answer is 3/2. Let's show the other technique. A minus 12 equals 42. Little bit, I probably would do distribution. I'll show you. If we divide by negative 4 in this is not a multiple. 42 is not a multiple of 4. So you're left with a minus 12, and we would reduce this. We'd reduce it by 2. So that gives you 21 over negative 2. Now, I'm still going to add 12 to both sides. And instead of writing 12, I'm going to write it as seconds. 12 is equivalent to 24 seconds. 24 seconds. You're left with a equals, I have negative 21 and positive 24, which gives me 3/2. This one we can't. There's no alternative because there's an R in Chewbacca and then there's an R outside of Chewbacca. So moving this does not benefit us. We want the R's to be on the same side. So the only thing I'm going to do is I'm going to distribute that negative 3. Better include that negative. So we get 33 equals 12R. Negative 3 times 9 is negative 27. Negative 3 times negative R is positive 3R. Now, before we start isolating, we're going to combine like terms. 33 equals 12R plus 3R is 15R minus 27. We'll add 27 to both sides. That gives us 60 equals 15R. Divide by 15, divide by 15, and we get 4. Wow. We get 4 equals R. Now, this is the mistake that most students make. They add 7 and 3 because they say, ooh, I know how to add 7 and 3. That's easy. This is multiplication. This is addition. Orders of operation always tells me to do multiplication first. You must do the multiplication. That is 7 plus 3 times 2g is 6g. 3 times negative 6 is negative 18 equals negative 29. Let's make this a little bit smaller. Let's move this. Let's move it over. Move this. That's good. Move you guys over. Now we have like terms. Let's combine like terms. We have positive 7 and negative 18. That would give me negative 11 plus 6g equals negative 29. Let's get rid of that negative 11 by adding 11. 6g equals, Signs are different, so I'm going to take the smaller from the larger. So that is negative 18. I have more negatives than positives. I'm going to divide by 6, and I get G equals negative 3. Now, I could do the other technique in this one because my G's are consolidated. So if I have 7 plus 3 times the quantity 2G minus 6 equals negative 29, I'm going to get rid of this 7. Can't get rid of the 3 because it's multiplying. I'm going to subtract 7 from both sides. 3 times the quantity 2G minus 6 equals negative and negative, makes a bigger negative. I'm going to divide by 3. I get 2G minus 6 equals negative 36 over 3 simplifies to negative 12. I'm going to add 6. 2G equals negative, what's that? Negative 6. I have more negatives than positives. Divide by 2, and G equals negative 3. Same answer. Number 12. All right, we have 2 different variables, so there's no shortcut. So I have to, the way that I get rid of Chewbacca is distributing. I'm going to distribute both of those. 5 times y is 5y. 5 times 8 is 40. Negative 1/2 times 1 is negative 1/2. Negative 1/2 times negative y is positive 1/2 y equals 1. We have like terms. We have 5y and positive 1/2 y, which makes 5 and 1/2 y. We have positive 40 and negative 1/2, which produces positive 39 and 1/2 equals 1. Lots of fractions. You can convert them to improper fractions, or you can just keep going. So we're going to get rid of that adding 39 and a half. You can also turn them to decimals. 39 and 1/2. That's 5 and 1/2 y equals, well, if I add 1 to negative 39 and a half, that's negative 38 and a half. Hopefully, logically, you know that answer, that you don't have to do the work. Okay? So, but if you wanted to, you could make a common denominator, etc. And so that's what you would do. So let's convert this. This is going to be 11/2 y equals, well, that's 38 times 2. 8 and 8 is 16. 76 plus the 1 more is 77. So that's negative 77 over 2. I have a fraction, so I'm going to multiply by the reciprocal. I'm not going to multiply 77 times 2 and 2 times 11. I'm going to look for cross-canceling. Denominator, numerator, which makes 1. 2 goes into 2 once. 2 goes into 2 once. What goes into 77? 11. 11 goes into it once. 11 goes into it negative 7 times. I'm left with y equals negative 7 times 1, which is negative 7. 1 times 1 is 1. And I must simplify that to negative 7. Number 13, some decimals. I can't do that. I'm not going to. I got variables inside and outside. So I have to distribute. 25.8 equals 1.2n. 0.6 times 12. 12 times 0.6. 6 times 2 is 12. 6 times 1 is 6 plus 1 is 7. We have 1 decimal point, so that is positive 7.2. 0.6 times negative 3. And, 0.6. 6 times 3 is 18, 1 decimal point. So it's going to be negative 1.8n. Let's combine like terms. The signs are different, so I'm subtracting. 25.8 equals, so that's going to leave me with negative 0.6n plus 7.2. Let's get rid of the things being added and subtracted. We can subtract the smaller from the larger. That gives us 6. That's 7, so I got to borrow. And that's, what's that, 8? And bring down the 1. I have more positives than negatives, so my answer is positive, 0.6n. Now let's divide by 0.6. 0.6 off to the side, 18.6 over 0.6. Move it one place, we'll move it one place. That equals 186 over 6. So 6 goes into both of those. 6 goes into 186 31 times. 6 goes into 6 once. So that equals 31. So any negatives? No. Oh, that negative in there. So look, I knew before I wrote the answer, I asked myself, are there any negatives? And I found one. I lost it. So that is really important, to just take the time to make sure that you look for negatives that you maybe dropped or lost. Bingo, that was a good one. That saved me a point. All right. Use the table to find the number of minutes you need to practice guitar on Sunday so that the mean number of minutes practiced per day is 30. Mean means the average. Average. So find the table, find the number of minutes you need to practice guitar Sunday so that the mean number of minutes practiced per day is 30. Well, we have Thursday, Friday, Saturday, Sunday. We don't know. We'll label that as X. So if we want the average of those 4 days to be 30, how do you get the average of things? You add them up. 20 plus 33 plus 32 plus my Sunday divided by 4 needs to equal, that average needs to equal 30. And that is your starting problem. Pretty neat. What do we do first? We are going to simplify. Let's simplify these like terms up on the top. 20 plus 33 plus 32. Well, that's 65. 85 plus x over 4 equals 30. This is that unique problem where we have a vinculum. I can't get to the 85 because it's being divided. 4 is dividing the 85 and the x, so I got to get rid of that 4 dividing, which is multiplying. I'm left with 85 plus x. These cancel, denominator, numerator, equals 30 times 4 is 120. Let's subtract 85. Subtract 85. X equals, well, we got to borrow 5. Got to borrow, and that's 3. So you have to practice 35 minutes in order for the, that's a horrible 5. In order for the average of the 4 days to be 30 minutes. Good? I like that. I know. I always say, you always say you like all of them. Oh, I do. I like them all. You buy 3 device trackers and a wireless charger. You use a coupon for 15% off your total purchase. You pay a total of $45.22 after using the coupon. The original price of the charger is $15.64. What is the original price of one device tracker? Okay, so let's write a very general problem. We have 3 trackers plus 1 wireless charger. And then we're going to multiply that. We're going to take a coupon for 15% off. So if we have 100% and we subtract 15%, we're left with 85%. You see that? That my total is going to be equal to 85% of the price. That's how much I have to pay. So this value, which equals, this is the total, this pays, I pay $45.22, but it is 85% of the total. This is the total. I have to add those two things together. So that is your equation. Now we would convert this to a decimal, but we just want to see this. 85% of the total should equal how much I pay. Now we can start plugging in things and changing things. So the original price of the charger is $15.64. Okay, so let's convert this to a decimal. I don't know how much each of the trackers are, but I do know that the charger is $15.64 equals the total amount that I paid. Okay, now we could distribute, or we can take the easy way. I'm going to say easy. We can take a more efficient way. We'll find out if it's more efficient. So on your test on Monday, you are going to be able to use a calculator. We are an hour and a half into this, and this is the first time that I am pulling out a calculator. And this is just for efficiency purposes. It's not that I don't understand. It's not that I can't do it. It's just that I'm being more efficient. 53.2. 53.2. So these cancel. You're left with 3t plus 1564 equals 53.2 or $53.20. All right, now we're going to get rid of the 1564 minus 1564. Let's add that 0 in there so we know where we're subtracting. So 4 you can't take, so you got to borrow. 4 from 10 is 6. 6 you can't take from 1, so you got to borrow. 6 from 11 is 5. 5 you can't take from 2, got to borrow. 5 from 12 is 7. 1 from 4 is 3. And 3 trackers is going to equal $37.56. But they don't want to know what the value for 3 trackers. We want 1 tracker. So I still have some work to do. I got to divide by 3, and I get t equals, and now I can divide that. 3, I'm not going to use a calculator because I'm still practicing my work. Decimal point, decimal point. 3 goes into 3 once. Bring down the 7. 3 goes into 7 2 times. 2 times 3 is 6. 1. Bring down the 5. 3 goes into 5 or 15 5 times. Bring down the 6. 3 goes into 6 2 times. So each tracker costs $12.52. Isn't it great to be able to do crazy math? That's a pretty challenging problem, and you were able to write an equation and solve for it and solve a really challenging problem. Nice job. The perimeter of the basketball court is 288 feet. What is the dimensions of the court? Well, we know that perimeter, let's remember what perimeter equals. The perimeter is the distance around an object. And the formula for perimeter, if you remember, perimeter equals twice the width plus twice the length, because you have 2 widths that you're adding and 2 lengths that you're adding. So the perimeter equals 2L or 2W plus 2L. So we know what the perimeter is, so we can substitute that, 288. We know what the length is. No, we don't know what the width is, W, and we know what the length is. It is 1.88 W. Okay, now we cannot add these W's because it's being multiplied. We have to simplify that. So 288 equals 2W. Now 2 times 1.88 W, that's going to be 1.88 times 2. 2 times 8 is 16. 2 times 8 is 16 plus 1 is 17. 2 times 1 is 2 plus 1 is 3. 3 decimal places, so that's 3.76 W. Now we're going to add these two like terms. 288 equals 5.76 W, We're going to divide both sides by 5.76. Divide by 5.76. For efficiency purposes, 288 divided by 5.76 equals 50. I'm loving that answer. So 50 equals W. Now, does that answer the question? What are the dimensions of the court? No, that doesn't answer it. That's just the width value. And it's feet, so the width is going to be 50 feet equals the width. And we know that the length, this is L, equals 1.88 W. So let's calculate the length. So the length is going to equal 1.88 times the width, and the width is 50. So L equals, let's use our efficiency calculator, 1.88 times 50 equals 94 feet. So if we're going to write the dimensions of the basketball court, the dimensions, I don't know if that's how you spell dimensions, dimension, T-I-O-N. Oh, hello, S-I-O-N, it's right here, dimensions, is going to be the length, which is, what is it, 94? 94 feet. We can do this, feet by 50 feet. You can also write 94 feet by 50 feet. Both of those answers will work for the problem. One angle of a triangle has a measure of 66 degrees. The measure of the third angle is 57 more than half the measure of the second angle. Oh! The sum of the angle measures of a triangle is 180. What is the measure of the second angle? What is the measure of the third angle? So notice I read it out. So I have this triangle. And I have three angles. I have 1, 2, and 3. And the sum of those angles, the first angle plus the second angle plus the third angle, must equal 180 degrees. Okay, so one of the triangles has a measure, so we'll call that first. Okay, the first one is 66, so we'll substitute that. The measure of the third angle is 57 more than 1/2 of the measure of the second angle. Okay, well, I don't know what the second angle is, so I'm going to keep that S. And I know that the third angle is going to be half plus 57. Half of the second plus 57 more should equal 180 degrees. Does that make sense? I hope so. So notice we only have one variable. That's not a distribution. We're just adding those. So that equals 66 plus S plus 1/2 S plus 57 equals 180. Let's combine like terms. We got 66. We got 57. Those are like terms. We have S and 1/2 S. 66 plus 57 is going to give me 6 is 12, 13, 123. S plus 1/2 S is 1 and 1/2 S plus 123 equals 180. Let's subtract 123. Subtract 123. 1 and 1/2 S equals, got to borrow, 7, 10, 7. 2 from 7 is 5. 1 from 1 is there. We have to convert that to a mixed or an improper fraction. Now we're going to multiply by the reciprocal, 2/3. 2/3. Uh-oh, did I make a mistake? I kind of feel like I made a mistake here. Let's see. What did Mr. Mac do? First angle is 66. The measure of the third angle is 57 more than half the measure of the second angle. 57 more than half of the second. That's the second. That's 6 is 12, 13. That's 123. That's correct. Minus 123. That's good. What is the measure of the third angle? Sum of the angles equals 180. First plus second plus third. 66. One angle. Okay. Reciprocal. 2/3. Stay with it. Apparently. It doesn't work. S equals. I made a mistake here somewhere. I don't know where I made the mistake because it's not going to come out nice. 3 does not go into 59 because 5 plus 9 is 14. 3 doesn't go into 14, so 3 doesn't go into 59. So 59 times 2 is 118 over 3. And for efficiency purposes, that's 39.3. Yeah, they think it's 38. So I'm going to assume that they, 39.3 repeating, I think was what, 39.3 repeating, yes, degrees. So the second angle equals 39.3 degrees. So if you want to find the third angle, you would put that third angle equals 1/2 the second plus 57, I think was what it was. Is it? Yeah, angle is 57 more than half the measure. That's correct, 57 more. I did plus 57. Oh, that's interesting. Now you got 57 there too. That is weird, huh? That's still right. I mean, it's correct. So if you want to find the third angle, you put half of 39.3 repeating. We'll round it. Let's make it 39. Because we're going to have to take, no, let's make it 40. Let's make this 40 for demonstration purposes. 40 degrees. And then 40 plus 57. Half of 40 is 20 plus 57 gives you 77 degrees. So the two angles are 40 and 77. The answer in the book is 38 and 76. And the only reason it's different is because they made a mistake. Unless you can find the mistake. I don't know where I made my mistake, but I don't think I did. 6, 6, 12, 13. Let's check. 57 plus 66 equals 123. Let's do 180 minus 123 gives us 57. I'm right. They're wrong. They made a mistake. 18. Find 3 consecutive odd integers that have a sum of 63. 3 consecutive odd integers. So let's take the first number. Let's pretend that is x, which is an odd number. So our second number, if this one is odd, how many to the next odd? Well, odd numbers are 1, 3, 5, 7, 9, 11. So notice that each odd number is plus 2 away. Plus 2. Technically, if we look at it from x, it's actually, when we look at odd numbers, 1, 3, 5, 7, 9, this is plus 2. But it is plus 4 from here and plus 6 from here. So 6 plus 1 is 7. So notice that the second number is actually x plus 2. And the third number is going to be x plus 4 away. But we're talking about odds and you're putting evens. But notice odds and evens are always going to be 2 away from each other. If you start with an odd number, it's 2 away. So find 3 consecutive odd integers that have a sum. So if we add these 3, if you add the first plus the second plus the third, it's going to equal 63. So the first is x, the second is x plus 2, and the third is x plus 4 should equal 63. Let's combine like terms. That gives me 3x. Let's combine like terms. Plus 6 equals 63. Very important. You will see this question on placement tests. It is a very typical problem that they will ask you. 57, 57 again, but this time 57. There's my problem. See, I kept thinking about it. You all must have been screaming 57, 57, and I wrote 59. What the heck was I thinking? That's supposed to be 57. And yes, 57 does go into 3 because 5 plus 7 is 12. Hello. Book was not wrong. Mr. Mac was wrong. Book was not wrong. Mr. Mac was wrong. Sorry. But at least I remembered. It clicked. You see that? I kept thinking about it. So 3 goes into 57. 3 goes into 3 once. 3 goes into 57. 1, 19. 19 times 2 is 38. Much like we said, the value was 38 degrees. Now we can still use this, but we're going to plug in 38. And if we plug in 38, half of 38 is going to be 1, 9, 19. 19 plus 57 is 76 degrees. So the second angle is 38, the third angle is 76, and the first angle is 66. Let's go. Isn't that weird how my brain did not forget? I saw that and it clicked because I was like 57, 57. See, it was trying to tell me too because I said something about the 57. All right, let's keep going. Divide by 3, divide by 3. X, which is my first number, goes in 1, 19. So my first odd number is 19. And now my second number is going to be 19 plus 2, or 21. And my third number is going to be 19 plus 4, which is 23. So my three numbers are 19, 21, and 23. And if we add those up, you get 63. Such a good question. All right, last one. What are we, 45 minutes, 45 minutes? What are we, an hour and a half in maybe? Probably. Let's work another half hour. 1.3 extra practice. All right, proportions. We have different ways of doing it. We're going to use method 1 here. Method 1 is cross multiply. We're going to use a calculator a little bit more in this section. So we have 9 times x equals 63 times 5. 9 times x is 9x equals 63 times 5. 63 times 5 gives you 315. 315. Let's divide by 9. Divide by 9, and we get x equals 9 goes in 3 times 27. 445 is 5, so it should be 35. X equals 35, which is correct. I just want to show you the other. When we get here, it's silly to multiply 63 times 5. I'll show you that when you have 9 times x equals 63 times 5, let's just divide by 9. Don't multiply that, because that gives you x, and now we can cancel 9 and 63. 9 goes into 9 once, 9 goes into 63 7 times. 7 times 5 is 35. No calculator needed. That's what I've been talking about. We have 15 over z equals 4/8. Hey, look at this one. You can simplify that right fraction if you want. Why do we simplify? To make smaller numbers. 1 times z, 15 times 2. And look what we just found. 1 times z equals 15 times 2. 1 times z is z. 15 times 2 is 30. Look how efficient that was. Here's another fun one that we can do a little trick. We can look at this as an equation. What's happening to my variable m? It's being divided by 2. What's the inverse of dividing by 2? Multiplying by 2. That 2 is in the numerator. That 9 is in the denominator. They do not cancel. However, This one does. That's 1. That's 3. 2 is still in the numerator. 3 is still in the denominator. You get 2/3 equals m. A little tricky. Let's do this one. We're going to multiply by the reciprocal, or the inverse of dividing by 7, which is multiplying by 7. We again cannot cancel this numerator with this denominator, but this numerator and denominator can. What goes into 16 and 6? 2 goes in 8, 2 goes in 3. And canceling now just makes it a whole lot easier. 7 times 8 is 56 over 3. That's simplified. I can't reduce that, because if I can't reduce it here, this denominator with this numerator, or this denominator with this numerator, then this will not be simplifiable. All right, we got a totem here. We got a person. We got a visitor center. You take the measurements shown in the diagram. The right triangles create each object, and its shadows are similar. Can the totem pole fall onto the visitor center? It's kind of morbid thought right there, of falling on people and the visitor center. So what we're going to do, we don't know the height of the totem because we have to find that. So we're going to take the height of the objects over the shadow of the objects. And we're going to do the totem, and we're going to do the man. So the height of the totem is x. The shadow of the totem is 40 feet. The height of the man is 5 feet 9 inches. Yuck. And the shadow is 5 feet. So if we do cross product, we're going to cross product these things. We're going to multiply those, and we're going to multiply those. Now, when multiplying, x times 5, that's 5x. When we multiply 40 feet times 5 feet 9 inches, well, we better get into inches here. Okay, so 5 feet is equivalent to 60 inches. So we're going to make that 60x. That's feet. 40 feet is equal to 480 inches. That's 40 times 12. So that's 480 inches times 5 foot 9. 5 foot 9 is going to be 60 plus 9, or 69 feet. Whew, okay. So let's do that. Let's do 480 times 69 gives me 33,120. 33,120. Let's divide by 60. Divide by 60. And that gives me x equals, let's divide this by 60. 552. 552 inches. And if it says, does it say, can the totem pole? So it is 43 feet away. So I do have to convert this into feet. If I have 552 inches, if I divide by 12, it'll tell me the number of feet. X equals 46 feet. So if the house is 43 feet away, then yes, it's going to crush this human, and it's going to crash into the visitor center. Can the totem pole fall into the visitor center? Yes, it can. Evacuate. Evacuate. Number 6. The table shows data collected by an athletic director after 2 football games. Use rates to compare the data for the games. So we can pick anything that we want to compare. Tickets sold, attendance, concession sales, social media posts. Okay, so let's do social media posts per attendance. Okay, how many social media posts per attendance? So social per attendance. So we'll do game A and game B. Social media is 125, and the attendance was 635. For B was 108 posts and 590 at that game. So this is social posts per person, technically per attendance. Attendee. This is posts per attendee. So we can't judge these at the moment because they're apples to oranges or apples to bananas because they don't have the same denominator. So if we find a unit rate, if we divide 635 into 125, so let's do 125 divided by 635, we get 19.6. We'll say 0. Let's round to the hundredths place. We see the 6. That means we're going to have to round up. So 0.2 posts per attendee. For A, let's do B, which is 108 divided by 590, which gives us 18. So that's 0.18 posts per attendee. So I'd say that the game A was more, it affected things more socially. Okay, so it has more posts per attendee. And the answer in the book is going to give you lots of different ones because we could have chosen any different piece of data. 5.3 yards equals how many inches? All right, so let's take 5.3 yards and we have to get to inches. So I'm going to start creating conversion boxes. And since I want to get out of yards, in that conversion box, yards needs to be in the denominator. Now, do I know yards to inches? No. I know yards to feet. I know that 3 feet equals 1 yard. So this is a value of 1. This is my first conversion box. And it's a value of 1. 3 feet is equal to 1 yard. So the yard in the numerator is going to cancel with the yard in the denominator, and we're currently in feet. I'm trying to get to inches, but I'm currently in feet. So I need to get another conversion box. I'm in feet. So in my second conversion box, I got to get rid of this feet. This feet is in the numerator. What's going to get rid of feet in the denominator? Do I know feet to inches? Yes, I do. I know that there are 12 inches in 1 foot. So now the feet have canceled, and I'm left with inches, which is what I want to do. This is in the numerator, this is in the numerator, this is in the numerator. 1 and 1 is in the denominator. We are multiplying. So 5.3 times 3, or let's do 3 times 12 is 36, and then 5.3. 6 times 3 is 18, 6 times 5 is 30, plus 1 is 31. 3 times 3 is 9, 3 times 5 is 15. 8, 10, 9, 1. 1 decimal place. And so this equals 190.8 inches. 5.3 yards equals 190.8 inches. Nice. Kilograms to milligrams. All right. So I have 0.6 kilograms, and I need to get to milligrams. So we need to have a conversion box. So I need kilograms in the denominator. I don't know kilograms to milligrams, but I do know kilograms to grams. And I know that there are 1,000 grams in 1 kilogram. So I'm out of kilograms. I'm in grams. So in my next conversion box, I want to get rid of grams. So I'm going to put that in the denominator. And I want to get to milligrams. So how many milligrams are in a gram? Well, that's also 1,000 milligrams is equal to 1 gram. Good. So I have this in the numerator, this in the numerator, this in the numerator. So each 0, when I multiply, is going to move that decimal point. So I have 0.6. How many zeros do I have? I have 1, 2, 3, 4, 5, 6. 4, 5, 6. That decimal point is going there. I'm going to start adding zeros, and I have 600,000 milligrams is equal to 0.6 kilograms. Nice. Good. Gallons to milliliters. All right. This is where it gets funky. Notice this is our first approximation. This little squiggly means approximately. So I'm going to have to do a conversion box. So can I go gallons to liters? Yeah, let's do gallons to liters. So I will provide you with this information during the test, but we can go here and we can say gallons to liters. And they will tell you 1 gallon is equal to 3.8 liters. We'll just use 3.8. 1 gallon equals 3.8 liters. So we have 3.8 equals 1 gallon. We are out of gallons and in liters. We've made it to the metric system. And now I want to go from liters to milliliters. So milli again is going to be 1,000 milliliters equals 1 liter. So we have 1.4 times 3.8 times 1,000. Remember, I have 1.4 times 3.8 and times 1,000. Each zero is going to move that decimal point. So I'm going to move this 1, which gets rid of one of the zeros. I'm going to move that 1, which gets rid of the 0. I'm going to move that 1 extra. So technically we have 140 times 38. And let's do that. 140 times 38. 8 times 0 is 0. 8 times 4 is 32. 8 times 1 is 8, plus 3 is 11. Move a decimal, move over a place. 3 times 0 is 0. 3 times 4 is 12. 3 times 1 is 3, plus 1 is 4. 0, 2, 3, 5. So that equals 5,320. So it equals, well, no, let's use approximate values, approximate sign. So it is approximately 5,320 milliliters. See what the book says. But that's not an approximation. They gave me 5,299.57. That's a poor approximation. You wouldn't go out that far if it was approximate. 280 meters equals how many miles? 2,080 meters equals how many miles? Okay, let's go from meters to feet. Meters to feet. That seems reasonable. So let's look meters to feet. Let's do meters to feet. So let's make that 3.3. So 1 meter equals 3.3 feet. So if we're going to write this, meters had to be in the denominator to cancel the meter in the numerator. So 1 meter equals 3.3 feet. We're out of meters and into feet. I want to get out of feet and go to miles. Okay. So feet has to go in the denominator. Miles. I know that 5,280 feet equals 1 mile. Why do I know that? I don't know. So we're out of feet and we're in miles. Now we have 2,080 times 3.13 divided by 5,280. So if we see that, we have 2,080 times 3.3 divided by 5,280. So let's use our efficiency calculator. Let's use our efficiency. 2080 times 3.3 equals 6,864. Let's divide it by 5,280. And we get 1.3. That's nice and clean. 1.3. So it equals 1.3 miles. That's nice. That's a good one. All right. Hour 2, we're probably on. A mako shark can swim up to about 20.5 meters per second. So mako can swim 20.5 meters per second. A bluefin tuna, can swim up to 72.5 kilometers per hour. Which animal has a greater swimming speed? So we have to figure out a common unit. So we're either going to push them to meters per second, or we're going to push this to kilometers per hour. Let's go to meters per second. So we're going to keep this one, and we're going to turn this one to meters per second. So my answer needs to be in meters per second. So I need conversion boxes. Well, first, I'm not going to do both of them at the same time. Let's start with kilometers. So kilometers needs to be in the denominator, and meters. So how many meters, how many kilometers? 1,000 meters equals 1 kilometer. So we're out of kilometers. We're in the meters that I need to get. Let's write another conversion box. But this one is converting the time. So hours. Hours is in the denominator. So in order to cancel it, it needs to be in the numerator. Can I go hours to seconds? No, I can go hours to minutes. So how many hours, how many minutes? 1 hour, 60 minutes. We're going to have to move this over a little bit. We have to move this over. Oh, it's not going to let me. Let's move this over. Let's ungroup that. No, I don't want that. I want this. Let's move that over. That. Yuck. Oh my goodness. Mr. Max making it hard. Okay, here's my second conversion box because I'm currently in hours in the denominator cancels with hours in the numerator, but I need to go from minutes to seconds. So minutes is in the denominator. Let's put it in the numerator to cancel it. Can I go minutes to seconds? Yes. 1 minute is 60 seconds. So I got this stuff in the numerator. I got this stuff in the denominator. My minutes cancel. I'm in seconds in the denominator. That's good. So I got 72.5 times 1,000 over 60 times 60. So let's start canceling this 0 with this 0, this 0 with this 0. So that gives me 72.5 times 10 over 6 times 6. Well, 10 times 72.5 is 725. 6 times 6 is 36. And let's use our efficiency calculator. 725 divided by 36. Oh, almost made a mistake. 36 equals 20.138. Repeating. So let's say 20.1. So this is 20.1 meters per second. That is the bluefin. And that's a pretty close race. And the mako is 20.5. So which is faster? Which is greater swimming speed? The mako is faster. Whoa, that was close. Fun problem, though. All right, number 12. Subway A reaches a top speed of 48 kilometers per hour. Subway B can reach a top speed of 45 feet per second. Which subway has a greater top speed? So A is 48 kilometers per hour, and B is 45 feet per second. So which one do we want to convert to? Let's convert this to feet per second. So first conversion, kilometers to feet. Let's see, kilometers and feet. I don't remember what that was. Let's do kilometers to feet. That's meters, so kilometers to feet. Oh yeah. So 3,281, we'll say 3,281. 3,281 feet equals 1 kilometer. Okay, that's my key that I'm going to use here. So 1 kilometer, 3,281. We are out of kilometers into feet. And now we need to go hours. Hours in the denominator. We got to go in the numerator. And then seconds. I don't know if anybody knows 1 hour is actually equal to 3,600 seconds. Some of you should know that. That'll help you. So what do we have here? These feet. No, we want to be in feet. Sorry, the feet doesn't cancel. It is the hour cancels, and we're in feet per second. So we have 48 times 3,281 feet over 3,600 seconds. Let's find a unit rate, because this is in a unit rate. So let's do this math here. 48 times 3,281 equals 157,488 divided by 3,600 gives us 43.7. 43.7. That is 43.7 feet per second. And this is 45 feet per second. So which subway has a greater top speed? Subway B is faster. Another close one. Number 13. I think this is the last problem, kids. Yes! Number 13. The surface area of a solid is 50,682,000 square millimeters. Is the surface area greater than 50 square meters? Explain. Hiya. Okay. So, is it equal to 1 square meter? We're going to take this problem out. It's late. It's 8:52. I'm not going to put a problem like this. If you want to see the answer, it's right here. Look at all that work we would have to do. No, thank you. We're going to call it a day. Don't worry about 13. It won't be on the test. Good luck.